All right, I'm on section 6.2.2, the next page there, and it talks about the saturated liquid line that we just referred to right here. Saturated liquid line. So we can see two separate pressures here. We should be able to draw some conclusions that, okay, the temperature, the saturation temperature for this one right here is much lower than the saturation temperature at this higher pressure. And we also refer to this region here as the subcooled region. And if I want to determine the enthalpy of a fluid, or a liquid rather, in the subcooled region, I could solve for it. Enthalpy of a subcooled fluid is equal to, well, we know that this is H sub F at that pressure, whatever it is, at pressure X. This is H sub F at pressure Y. So I would look up the H sub F at pressure X or Y. So if this was 100 psia and this was 50 psia, I can see that there would be a lower saturation temperature for the 50-pound pressure line than the 100-pound pressure line. In either case, I start with the H sub F for that pressure, and I subtract C sub P times T saturation, which is these, minus whatever actual temperature you are for the given pressure. So you can see it depends on what pressure you're at, because there's going to be a different saturation temperature for the higher pressure than the lower, and then you're going to be subcooled at that pressure somewhere along this line. If you're looking at this right here, you'll see that equation right in the middle. Enthalpy of a subcooled fluid can be determined using that equation. Very important. Now, if I knew the temperature was 212 degrees Fahrenheit, I go up and down this line on the TS diagram and I find 212 degrees right here. I would then see at that temperature what its corresponding pressure is. And we know that 14.7 psia is its corresponding saturation pressure. So if I had 212 degree water in my hand and it was at 14.7 psia, I know that I would be at the H sub F line. If I was anything less than 212, not equal, less than, I would be subcooled at that temperature and pressure. Subcooled, I would be down here in this region. So that's pretty cool. So where vapor starts to form is the vapor pressure. And I know vapor pressure for 212, saturation pressure, is atmospheric. Once again, if I was to divide this line right here at the critical point and divide it vertically, this right here, don't forget, is your saturated liquid line. This right here on the right side of the critical point is our saturated vapor line. And those are K&A requirements in the lower right-hand portion of that paragraph. Identify the terms, saturated liquid line. Identify also on TS, solids, liquids, gases, vapors, and fluids. Well, for the most part, this is all liquids on our TS diagram. This is a subcooled liquid. This is a liquid vapor mixture. And then over here is a superheated vapor. As I would come across the vaporization line and then go up, we know that this is the superheat region.